JNBridge provides high-performance Java and .NET interoperability tools to meet the demands of today's heterogeneous computing environments. In this first of a three-part video series, I'm going to show you how to build a JNBridgePro Proxy DLL that will bridge between Java and .NET. Let's get started by using the log demo that ships with JNBridgePro. Let's navigate the All Programs Explorer and find the JNBridgePro product tree. Note that we have two distinct versions of the proxy generation tool. The first executable in the list supports legacy applications built on the .NET 2.0 to 3.5 framework. The second executable in the list supports the more recent .NET 4.0 framework. And since we want our eventual proxy DLL to support Visual Studio 2010 and its underlying .NET 4.0 framework, we will select the second executable in the list. Next, we need to begin setting up our environment. Because our requirement is to access a Java API from .NET, we will select Create New .NET to Java Project. The next step is to define our project environment's class path, to point to the collection of jar and class files that make up the Java-side API we wish to access from .NET. We do this through the Project Edit Class Path option. In this case, we're going to add some class path information. So under my C directory, temp, I've placed the log demo. Underneath the log demo, you'll see the two core logging jar files. I'll go ahead and select those. We also have a single class file that we need access to. It's called Java class, and we're going to access this later from the proxy generation tool. In this example, we will set the log demo folder as the package's root location. Now that we have our local JNBridgePro class path defined, we can begin to add our core logging classes to our environment. We can do that through Add Classes from jar file. Now here's where we go out onto the file system and physically grab the binaries that we're going to be used in our project. Through reflection, JNBridgePro begins to expose a list of Java-side available classes in the far left environment pane. Now note this warning regarding the missing classes. In this case, we can ignore the message as we'll not be accessing any of the JMS or mailing features in our logging project. So I'm just going to go ahead and OK out of this. Next, as described in the log demo supporting documentation, we'll add our single class to our project using a fully qualified class name that leads to the Java class file. Let's go to our project, add classes from class path, and load this resource. Remember that the log demo was at our root folder in our local class path definition earlier, and that log demo or logger demo is a subfolder that actually contains our Java class of interest. Therefore, this definition, loggerdemo.java class, is now fully qualified. Note the Include Supporting Classes option. This tells the system to reflect all the classes in the object hierarchy in the environmental view pane. If you're not sure which classes you might want to work with directly from .NET, this is a good exploratory option to keep enabled. Now that we've exposed a list of all the available and supporting classes to our Java API in our environment pane, we can now begin to select individual or all the classes in the environment that we would want to include in our proxy DLL for direct access from .NET. Note that one can drill down into the object tree and preview supporting details like method and property names. You want to use the Add button to move individual classes into the exposed proxy list, or the Add Plus button to also include all the supporting classes. In most cases, it's not necessary to expose an entire API this way. Rather, one would want to refine the list to include only those classes that will be directly accessed from .NET. However, for this demonstration, we'll go ahead and proxy the entire logging API and all its supporting classes, as there's really no harm in doing so, other than it does slow down the build process somewhat. With the entire logging API now listed in the Exposed Proxies pane, we're now ready to build our proxy DLL. But first, note that you can explore in more detail the signature content of your newly proxied Java API. Our final step is to build our exposed proxy list into a binary proxy DLL that can then be used by any .NET developer needing access to these new logging features. And the best part is, the features you choose to expose will be presented to the .NET developer in a format that's familiar. It'll be native .NET versus Java. Note that I've defined a location and name for our new logging DLL. With our DLL name defined, the proxy generation tool will now begin the final build for us. And as a footnote, these builds can also be run in batch mode or directly from Visual Studio using our plugin architecture. With the build now complete, let's look for the presence of our new logging DLL. Well, there it is. This concludes tutorial 1. Congratulations, you're now ready to move on to the second tutorial that covers .NET developer usage of this newly created proxy resource from a Visual Studio 2010 project.